This is number 3 from the 2000 AP Calculus AB exam. So they give us the graph of the derivative of a function, and they tell us our interval is from -7 to 7 right here, and that we've got horizontal tangent lines at x equals -3. So horizontal tangent line at x equals -3, at x equals 2, and x equals 5. And a vertical tangent line at x equals 3. So right at this change here, we would have a vertical tangent line. So for part A, we need to find all values of x on that interval at which f attains a relative minimum. Now we know we have a relative minimum when our derivative changes from negative to positive, right? So our function goes from decreasing to increasing, but the derivative changes from negative to positive. So the derivative looks like it changes sign from negative to positive at x equals -1. That's the only place. Negative values to positive values. So our answer is x equals, because f prime Okay, part B. Now we're looking for a relative maximum. So that'll change where the derivative changes from positive to negative. That's happening at x equals -5, positive values to negative values. So now positive -5. Okay, now we're ready for part C. We want to find all the values at which the second derivative is negative. So what does that mean for our second derivative to be negative? That means that our first derivative must be decreasing. So where is our first derivative decreasing? Well, it looks like we're decreasing from -7 until -3. So let's write down that interval, -7 and then f prime continues to decrease, let's see, from -2 until 5, but something funny is happening right there. Our second derivative is actually undefined here because we've got a vertical tangent line. So we can only say that the second derivative is negative from 2 until 3, and then from 3 to 5. So we need to break up that interval. So we've got 2 to 3, and then 3 to 5. Okay, last part, D. So we want to know where our function attains an absolute maximum. Well, that's going to happen either at an endpoint, so it could be -7, it could be +7, or at the local maximum, and we decided that that was happening at x equals -5. That was from part B. So let's see what's happening on our graph up here. Now we can immediately rule out x equals -7 because this part of our derivative is positive, which means that our function is increasing. So our function increases from negative 7 to negative 5, so x equals negative 7 cannot be our absolute max. So let's make a note of that. We can cross this out, and we can say f of negative 5 should be greater than f of negative 7, because f prime is positive on that interval from negative 7 to negative 5. Okay. So now let's decide between negative 5 and 7. So think about what's happening with the function. Here's x equals negative 5. Our derivative is negative, which means that our function is decreasing from negative 5 to negative 1. And then our function is positive here, 0, and then positive here. So our function is going to spend a lot more time, if that makes any sense, increasing than it would be decreasing. Right here, negative 5, decrease, 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 and then lots of increasing at different rates, but still increasing. So I would argue that our relative max, or our absolute maximum, has to be happening at x equals 7. So there are going to be a number of ways to actually explain that. So let's state that our maximum is definitely happening at x equals 7. This is our solution. Because, and I'm going to say the amount of positive change on negative 1 to 7 is greater than the negative change on negative 5 to negative 1. And any variation of that is really just fine.